Hello, our project focuses on the creation of an ankle-foot orthotic, or an AFO, at an orthotic and prosthetic clinic located in Ann Arbor. Today we will discuss our goals and objectives of the project, the current process to create an orthotic, the methods we used, and our findings and recommendations. We have three main objectives: evaluate the current process of making an orthotic, identify areas of waste and inefficiency, and propose advantages and disadvantages of 3D printing as a new solution. The current process begins when the practitioner makes a mold of the patient's limb using a foam material. This creates a negative mold of the patient's limb. The foam mold is then filled with plaster and left to dry. This creates a positive plaster model of the limb. Workers then shape the positive model to eliminate any blemishes. The technician then uses the model to create a plastic mold. The final step is to put all orthotic components together. Our project will focus on Step 4 of the current process. We divided Step 4 into subtasks and did our analysis on these subtasks. The process was divided into the following tasks. 1. The worker gets the order form and mold from the front desk and brings it back to the bench. 2. The worker evaluates what needs to be done to create the AFO and takes it to the vacuum station. 3. The worker puts a nylon sleeve on the mold and cuts a sheet of styrofoam to put it in the oven to make it malleable. 4. The worker puts the styrofoam mold and turns the vacuum on to seal the styrofoam to the mold. 5. The worker cuts plastic material and puts it into the oven to be heated up. 6. Worker removes the styrofoam where he would like the plastic piece to be placed. 7. The worker takes the sheet of plastic and places it accordingly. 8. The worker waits for the plastic to harden, removes the piece, and cuts any excess material. Now that you are aware of the current process to create an AFO, we will discuss which methods we use to analyze the process. We started with the time study analysis, focusing on finding the total average time to create one AFO. A few of the benefits of determining a normal or standard time, including more accurate technician work schedules, visibility into technicians' productivity, and more precise dates of completion for patients. By performing an in-depth study, we attempted to find sources of wasted time and analyze ways to remove it. After performing our time study and establishing the longest part of our process, our team used MODEPs to break this part down. By combining our MODEPs analysis with our potential layout changes in SketchUp, we will be able to give concrete reasoning on the potential time that could be saved. Next, we conducted a critical incidents analysis. We interviewed 3 different individuals and asked about their memories of actions or direct observations of others. We found 5 main problems shown here. Our final method was to create the workstation layout in SketchUp. While touring the facility, we measured the dimensions of the workbench, the distance from the workbench to the oven, and the dimensions of the entire workspace. By using SketchUp to design the main workstation and workplace, we were able to analyze the traveled distances. Now we will discuss our overall findings. From our time study analysis, we found the normal time to be 135 minutes. Our time study indicated that Step 4 takes the longest amount of time. Due to the multiple subtasks included within Step 4, we also performed a time study analysis on each subtask. Following this, we performed a MODEPs analysis to find where time could be eliminated. Here you can see Part 4 of the process broken down into MODEPs codes and their respective times in seconds. The MODEPs analysis predicted it takes about 46.5 seconds excluding the wait times. The plastic step takes the longest amount of time, with a time of 24.8 seconds. Based on this estimation, we would recommend to move the plastic station closer to the oven and vacuum station. Overall, this change would reduce the process time by 10 seconds. Analyzing the 5 main errors that are common among workers, we found that errors 1 and 5 were adjustment errors, 2 and 4 were forgetting errors, and 3 was a substitution error. By increasing the strength of the vacuum, checking the strength of the mold, and placing timers at the workstations, we can eliminate a majority of these critical incidence findings. SketchUp was used to help identify areas that need improvement in the current layout. First, the oven should be placed only 1 meter away from the vacuum station. This change would reduce the overall process time by about 2 seconds. Next, the pattern paper station should be only 1 meter from the vacuum station. Moving this station 4 meters closer would eliminate about 4 seconds from the process. Overall, using the tools we have learned throughout IOE 463, our team has provided great information for ways to minimize waste and maximize productivity at the prosthetic and orthotic clinic. As a final deliverable to our project, our team did research into the second potential process utilizing 3D printing. Using a 3D printer to create an AFO would eliminate a majority of the material waste, improve the overall process time, and decrease the variability between molds. We hope you enjoyed learning about orthotics as much as we did, and thanks for listening to our presentation.